Welcome to your custom tailored deep dive. I'm your host, and I have to say, I am super excited about what we're looking at today.
Oh, me too. Thanks for having me. This one is just incredibly unique.
It really is. Like, normally when you think about high-level software engineering, right, the kind
Yeah.
of complex, concurrent back-end systems that keep global telecommunications running, usually picture, I don't know, dark rooms, glowing monitors.
Right. Endless lines of code,
Yeah.
lots of coffee.
Exactly. You certainly do not picture a guy standing in his backyard just staring at a tiny piece of a Brazilian tea plant.
No, you definitely don't. But that is exactly where we are today.
Yeah. So today we are exploring a highly specific, seemingly humble blog post. It's dated March 13th, 2026, from a site called kianemgi.org.
Which is just a fascinating piece of documentation. The author goes by Ang, and he describes himself very simply as an old software plumber.
An old software plumber, I love that.
Right. And while the specific post we're examining is titled Notes on Gardening Part 826, this is not your typical weekend gardening blog.
Oh, far from it. Like, on the surface, sure, it reads like a quick status update about some plant cuttings. But our mission today is to dig into the margins, like the real methodology of this single post.
Yeah, we're looking for that intersection.
Exactly. The intersection of strict software engineering principles, relentless human curiosity, and, well, the unpredictable natural world. And it's all just hiding in plain sight within the archives of this one website.
It really is.
Okay, let's unpack this, because we need to start with the actual experiment Ang is running here. He's attempting to propagate a plant called Brazilian tea.
Right, or Stachytarfeta cayennensis, if we want to be exact.
Right, right.
And his methodology is really what immediately stands out because, the conventional wisdom for propagating this specific species dictates that you take stem cuttings that are roughly, say, 10 to 15 centimeters long.
Which is a pretty big chunk of the plant.
It is. And the logic there is purely biological risk mitigation. You take a substantial piece of the parent plant to ensure it has enough, like stored carbohydrates, enough mass, enough latent energy to actually survive the trauma of being severed.
Because it's a huge shock to the system.
Exactly. It needs those physical reserves to stay alive long enough to develop an entirely new root system.
So you basically take this massive chunk, stick it in the soil, and just bank on its internal reserves.
Yeah, that's the standard way.
But Ang is completely throwing out the 15-centimeter rule here. He is attempting a technique he refers to as the single node method.
Right, which is taking the plant down to its absolute minimum viable product.
Wow, yeah.
He's isolating just the individual nodes. Those are those tiny, highly active sites of meristematic cellular growth on the stem. And he's trying to coax an entirely new, fully functioning plant out of just a fraction of the starting material.
And he actually gives us a real-time status update in the text, right? Like, he notes that tiny shoots have already started sprouting from these individual nodes.
Which is a really great initial sign.
Yeah, but he's also remarkably precise with his observations. He adds that the root systems aren't visible yet. So his conclusion is that they will, quote, likely have to wait a week or two for confirmation.
What's fascinating here is the underlying philosophy of his approach. He is aggressively optimizing for efficiency. He's trying to maximize output from the absolute bare minimum of input. But beyond just the efficiency, if you look closely at the vocabulary he chooses to use in this post.
Oh, the vocabulary is wild.
Right. He writes, we can conclude that using node cuttings is an effective way to multiply the plant species we've tested so far. And then he outlines his roadmap, saying, we'll explore more species soon to validate this method.
Validates this method.
Exactly. And he says, as we gather more data, we'll be able to refine the process even further.
Yeah, that vocabulary is just the dead giveaway. Like, he doesn't sound like someone hoping for a good spring harvest, you know? He sounds like a back-end developer running a beta test in a sandbox environment.
Spot on. He's executing a systematic protocol. He's explicitly validating methods and gathering data to refine a process.
It's like he's treating the dirt in his backyard like a controlled laboratory environment.
Yeah, there's absolutely no reliance on folk wisdom or, the myth of the green thumb here. He formulated a hypothesis about minimal biological material, and he is just running a stress test.
I think the best way to visualize what he's doing is to look at it through the lens of system architecture.
Oh, I like that.
Yeah, like the traditional method, taking that massive 15-centimeter cutting with all its leaves and stored energy, it's a lot like trying to copy an entire bloated virtual machine image.
Right.
You're cloning the whole operating system, the temporary files, the user profiles, literally everything. And it's incredibly safe because all the dependencies are baked right in. But it's heavy, it's resource intensive, and it severely limits how quickly you can scale.
It's a very safe, but ultimately brute force approach to replication.
Exactly. But Eng's single node method, that is the biological equivalent of trying to clone a whole system from a single line of code, or like writing a minimal Docker container.
A bootstrap script, basically.
Right. You are providing nothing but the absolute core set of instructions, the single node, and relying entirely on the external environment to provide the runtime dependencies needed to compile the system.
That is such a good analogy.
Thanks. And if you pull it off, the scalability is just staggering. You could theoretically spawn dozens of plants from a single stem.
Right, but doing that requires an incredibly precise understanding of the environmental variable.
Completely. The humidity, the soil matrix, the light, because there is absolutely zero margin for error.
Yeah, if the environment is off by even a fraction, the container crashes. There are no built-in biological reserves to sustain that single node if, say, the soil is too dry or the light is too intense.
Right, it just fails.
It fails silently and it fails quickly. It is your classic high-risk, high-reward optimization problem.
Which naturally leads us to ask why. Like, why is a guy in his garden gathering data sets and validating biological methods? Why is he treating a Brazilian tea plant like a piece of modular code?
Well, the answer is sitting right there in the subtitle of his website.
Yeah.
It reads, Journal of an Old Software Plumber Night Long, Tinkering with Free Libre and Open Source Software. Eng is a technologist through and through, and his specific areas of expertise are incredibly telling here.
Yeah, looking at the project lists and the notes in his sidebar, the scope of his technical toolkit is heavy.
Very heavy.
He isn't just writing like basic HTML scripts. He has extensive documentation on Elixir, Erlang, Python, Haskell, Go, and Rust.
And that specific combination of languages provides the blueprint for how his brain works. Like Python and Go are fantastic for rapid utility and backend services, while Haskell is this purely functional language known for being mathematically rigorous. But the presence of Erlang and Elixir, that is the most illuminating detail to me.
Why is that?
Because those languages were designed specifically for building massively scalable, highly concurrent, fault-tolerant systems. We're talking about the infrastructure that routes global telecommunications.
Wow. So they're designed for environments where a million things are happening at once.
Exactly. And if one single component fails, the entire system must find a way to stay online. He really is a true software plumber, spending his nights deep in the pipes of how these complex systems maintain state and manage unpredictable inputs.
And when you spend your nights architecting concurrent systems in Erlang, I guess that mental model doesn't just switch off when you walk outside.
No, it really doesn't. You don't just toss a handful of seeds into the dirt and hope for rain. You look at a garden and you see a massively concurrent biological system.
Like pests, weather changes, soil degradation, those are all just unpredictable inputs.
Precisely. And to manage them, you systematize. You isolate variables. You basically apply strict version control to your physical reality.
And I don't think anything demonstrates that version control better than the title of this very post. I mean, he named it Notes on Gardening Part 826.
The sheer discipline of that number is staggering.
Part 826. Like, I want you to think about your own hobbies for a second.
Yeah.
Have you logged your progress on literally anything 826 distinct times?
I definitely haven't. But by applying this open source, rigorous documentation standard to his garden, Eng is actively stripping away the mysticism that usually clouds horticulture.
Oh, that's true. People do tend to treat gardening as this innate art, right? Like you either have the green thumb or you don't.
Exactly. But Eng approaches it as a series of deterministic iterative tests. He logs his successful compiles, sure, but he is equally meticulous about documenting his bugs.
Oh, yes. We see that perfectly illustrated in his sidebar. Just a few days prior to the Brazilian tea experiment, he published a post called Part 825, Leggy Seedlings Again.
Right.
He is literally logging a recurring error in his plant development environment.
Yeah, and a leggy seedling, for context, is a specific biological reaction where a plant grows too tall and spindly. It's usually because it's desperately stretching toward an insufficient light source.
Mm-hmm.
By documenting it with the word again, he's acknowledging a persistent bug in his setup. He recognizes the pattern. He understands the biological mechanism, which is phototropism, and the implication is clear.
He needs to adjust the environmental input.
Yes.
Yeah.
Perhaps the lumen output or the distance of his grow lights just to optimize the output.
Okay, I am going to push back on this approach a little bit, though.
Sure, go for it.
Because, you cannot fully map a software paradigm onto a biological ecosystem, right? Plants are not code.
No, we aren't.
If you have a bug in Haskell, you trace the logic, you fix the syntax, you hit compile, and the program runs perfectly. But a garden is non-deterministic. A sudden late frost or an aphid infestation isn't a syntax error. It's a massive, unpredictable hardware failure that you just cannot control.
That's very true.
So, does this ultra-systematic, hyper-data-driven approach risk missing the point? By trying to force the unpredictable, chaotic beauty of nature into a version-controlled spreadsheet, does he lose the essence of what a garden actually is?
See, that is a highly relevant critique, and it's actually a really common trap for technologists to pivot into biology or agriculture. They attempt to, hack the system, and then they become profoundly frustrated when the biological organism refuses to respond with the immediacy of a microchip.
Exactly.
But if we analyze Eng's actual behavior in the text, we see he completely avoids this trap. Notice how he reacts to the Brazilian tea experiment. He sees the tiny shoots, but he observes no root development. A pure hacker might try to force the issue.
Like applying synthetic rooting hormones or something?
Right, alter the temperature, add hormones, or just abandon the test as a failure.
But instead, he explicitly writes, we'll likely have to wait a week or two for confirmation.
Yes. Wait a week or two. That single sentence resolves the tension between his two worlds. Because despite his rigorous data gathering and systemic optimization, Eng possesses a deep, deferential respect for nature's timeline.
Wow, yeah.
He understands that while he can optimize the initial conditions crafting that perfect single-node Docker container, as you called it, he cannot rush the biological compilation process. He has to surrender to the plant's internal clock.
That is a brilliant synthesis. It's an engineer's drive for efficiency matched with a master gardener's inherent patience.
Exactly. He builds the perfect runtime environment, but he lets the system boot at its own pace.
That is a phenomenal balance. And what becomes apparent as you explore qianmeng.org is that this methodical, patient documentation is not isolated to his raised garden beds. I mean, he applies this exact same framework to his entire life.
He really does.
Moving from the physical dirt into his digital garden, the sheer scale of his archiving is almost difficult to comprehend.
We were looking at a modern Renaissance ledger, basically. The volume of output detailed in his blog's timeline is extraordinary. Just in the year 2025 alone, Eng published 730 individual posts.
Unbelievable. And in 2024, the number was 732.
Yeah.
That is a baseline of 2 fully formed, documented thoughts published every single day, without fail, for years on end. And the archive itself stretches all the way back to 2011.
Maintaining that level of output requires a relentless, almost automated consistency, but the volume is only half the story here.
Right.
The immense variety of the subject matter is where his system truly shines. He's not just iterating on snippets of Go or the growth rate of Brazilian tea. He is systematically iterating on the human experience.
Let's look at the cross-domain learning he engages in just within the month of March 2026 alone. He seamlessly transitions from publishing a deeply technical breakdown titled Analyzing Wi-Fi 7 directly into notes on Haskell programming.
Right.
And then almost immediately he pivots to notes on fish keeping, adapting water parameters.
Which fundamentally is just another exercise in managing complex state.
How do you mean?
Well, in software, you manage memory allocation to prevent leaks, right? In an aquarium, the water chemistry is your state. An ammonia spike is essentially a memory leak that threatens to crash the entire system.
Oh, wow.
And you patch it by managing your biological filtration. The domain changes entirely, but the mental model remains exactly the same.
That makes so much sense. And he doesn't stop there either. He pivots again to write Notes on Dieting, the truth about icosapent, diving into cardiovascular health supplements, from functional programming to lipid management to the gelatinous pearls on plant leaves, all the way to documenting his ongoing bougainvillea cultivation. I mean, the breadth of his curiosity is just dizzying.
It is. And if we connect this to the bigger picture, Eng's website ceases to be just a blog. It's a publicly accessible, transparent ledger of a human brain processing the world in real time.
Yeah.
He's taking the core ethos of the free libre and open source software movement, Transparency, collaboration, and iterative improvement. And he's applying it to everyday existence.
And he wears those values on his sleeve, too. He features a Do Support section prominently on the page, linking out to the Electronic Frontier Foundation, the Free Software Foundation, the Tor Project, and Wikipedia.
The heavy hitters.
Absolutely. He also links to GitHub and CPAN for his own software packages. These are the foundational pillars of a decentralized, accessible, and open internet.
Because he operates on the profound belief that knowledge is only truly valuable when it's out in the open.
Mm-hmm.
Whether he's dissecting a complex Elixir library, figuring out the optimal lumen output to prevent a seedling from getting leggy, or detailing the exact pH requirements for breeding fish, he refuses to lock his findings away. There are no paywalls here.
No.
There are no proprietary algorithms dictating who gets to see his work. He is actively democratizing his own daily curiosity.
Okay, here's where it gets really interesting. When you zoom out and look at the entire ecosystem, the plant cuttings, the concurrent code, the massive decade-spanning archive, you realize that Ang isn't just propagating Brazilian tea from single nodes. This entire blog is a massive propagation engine for ideas.
Oh, that is the perfect way to contextualize it.
Right. Every single day, he takes a microscopic node of learning. It might be a tiny discovery about packet routing in Wi-Fi 7, a small adjustment to the nitrate levels in his fish tank, or just a single syntax error in his Haskell code.
Yeah.
On their own, these are just tiny, isolated nodes. But instead of discarding them or keeping them hidden in a private notebook, he plants them in his digital garden. He logs the data, he publishes the post, and he trusts the process.
It really does.
And over 15 years, those tiny, seemingly insignificant daily nodes have compounded and grown into a massive, interconnected force of knowledge.
And much like his single-node plant experiment, building an archive of that magnitude requires an incredible tolerance for vulnerability.
Oh, absolutely.
I mean, a single post about a leggy seedling or a failed piece of code might seem trivial, even embarrassing to some people. It's just a tiny shoot with no roots. But when you chain thousands of those transparent moments together over a decade, you build a profound, resilient ecosystem of understanding.
It's the ultimate testament to the power of compounding interest, applied directly to human curiosity.
Very well said.
So, as we wrap up this exploration, we really have to ask, why does this matter to you? Why should you spend your time unpacking the digital journal of an old software plumber from 2026?
Good question.
It matters because Ang proves definitively that you do not need to be a grandmaster to contribute something meaningful. You don't need to have the entire architecture mapped out perfectly before you hit publish.
Right.
You just need to possess a relentless curiosity about the world around you. You must be willing to document your single nodes of discovery, no matter how chaotic or insignificant they might seem in the moment, and you must have the discipline to iterate on them day after day.
He represents a total rejection of the modern internet's demand for, hyper-polished, finalized content. Ang is showing his work in real time.
Yeah, warts and all.
Exactly. He's letting us see the leggy seedlings, the failed compilations, and the slow, agonizing wait for the roots to establish. That level of vulnerability, that unwavering commitment to the iterative process rather than the polished product, is incredibly rare today.
It makes the vast, noisy internet feel a little bit more intimate, a little more human, and significantly more fascinating. It's a powerful reminder that there is profound value in simply paying close attention to the intricate details of our own daily lives.
And crucially, in sharing those granular details with the world, adding to the collective open source project of human knowledge.
Absolutely. So we want to leave you with a final thought to mull over as you step back into your own routines today. We have spent this time exploring how Ang takes the smallest unit of a plant, or the smallest daily observation, and leverages time and meticulous documentation to grow them into something monumental. So, if you were to break your own daily routines, your own niche hobbies, or your own passing interests down... Wait, let me rephrase that without pausing. If you were to break your own daily routines down, what single node habit or tiny curiosity could you plant today that, if you documented it every single day like Ang, would yield a massive forest of knowledge 15 years from now?
The soil and the raw materials are already there in your life. It simply requires the discipline to plant the node and the patience to wait for the roots.
Thank you so much for exploring the Qianmeng archives with us on this deep dive. Keep tending to your own gardens, digital or otherwise, and we will catch you on the next one.